Hi everyone, welcome to our video today. Today's lesson is going to be analyzing rational functions. So what we're going to be doing today is taking a look at graphs and how they kind of graph out as a rational. So the very first thing that we're going to talk about here today is something called a point of discontinuity. This is basically a gap or a hole in your graph. So it's a point on the graph that does not exist. Okay, so that's basically what you need to know is it doesn't exist on the graph. So our very first example here we have is given this function, determine any gaps in the function. So we have a few steps that we can follow along. That's going to help us figure out what our point of discontinuity is. By the way, I can call point of discontinuity POD for short, so I'm just going to call it POD or POD for short. So the very first thing I need to do is factor out numerator, factor out denominator, cancel out all the factors, and then state with my NPV that I canceled out, I'm going to sub in and solve for the missing variable. So here we go. Let's factor this equation out right here. So my numerator here, f of x, is my function. My numerator is going to become x squared plus 3x plus 2. If I factor that out, that's just x plus 2. And I have a x plus 1 with it. On the denominator, that x plus 2 is all together, so I'm going to put it in brackets x plus 2. I notice that my numerator and denominator have the same factors, so I can cancel those out. I'm left with an equation for function f of x equals x plus 1. So that's what I'm left with, and that's going to be my final function, or simplified function as well. My POD was what I just canceled out. So POD is going to be an ordered pair, by the way. So I canceled out POD. This is going to be at x plus 2. I'm going to set that equal to 0 and solve for x. So this is x equals negative 2. If I know x equals negative 2, I'm going to find my y value with it. I'm going to plug it into f of x, which is f of negative 2 now, equals negative 2 plus 1. So f at negative 2 is going to equal negative 1. Therefore, I'm going to have a POD at coordinate negative 2 comma negative 1. So at negative 2, negative 1, I'm going to draw a circle right there denoting that that's a coordinate that does not exist. And then I'm just going to graph the rest of this function. That's at y equals 1, I'm going to have a coordinate there. And if I go up 1, right 1, I'm going to build a few coordinate dots that way, down 1, right 1. To get to my POD, I'm going to skip it and continue on with a few dots there. All I'm going to do now is connect my graph, and then I have my function with a POD in it. So it's going to start there, going outwards. There we go, that's half there. And the other half is going to go down. And there we have it. So that's example 1. In our next example, we're doing very much the same thing as the previous example, but this time we're going to list off some characteristics as well. So the first thing I'm going to do, of course, is factor. So I'm going to factor the top, factor the bottom. In my numerator, this is a difference of squares, so this is going to get me x plus 2 and x minus 2. In my denominator, this is going to get me x plus 2 and x minus 3. And again, I see numerator, denominator. I can see something that I can cancel out, so I'm going to clean that up. So I'm left with the final function of x minus 2 over x minus 3. Again, I'm going to be, as I canceled out these factors here, I'm going to start off by finding my POD. Off to the side here, I'm going to say POD is going to be at x equals, and if you flip that right away, x equals negative 2. Then my y is going to equal negative 2 minus 2 over negative 2 minus 3. This is going to get you negative 4 over negative 5, which is just 4/5. There we go. So my POD, the coordinate for it, is going to be at negative 2 and positive 4/5. Other things that I'm going to try to do as well, now that I have a simplified equation, I'm going to start off by finding my vertical asymptote. This, of course, is always our denominator, and this means that x cannot equal 3, so I have a vertical asymptote at x equals positive 3. My horizontal asymptote, I'm looking at the degrees, that's 1 over 1, so that's going to be y equals 1 over 1 for coefficients, which is at 1. Point of discontinuity we just found, and that there was at negative 2 and 4/5. I'm going to start graphing to finish off these last three characteristics, but I need a graph first to do these last three characteristics. So on my graph here, I'm going to find x equals 3, draw a line straight down. I'm going to find a line y equals 1 and draw a line straight across. So I have my two asymptotes on my graph already. I'm going to draw a circle as best as I can at negative 2 and positive 4/5, which is right below our line there. So that's a circle. And now I'm going to find some coordinates nearby. And to find coordinates, you're going to go straight to your graphic calculator. You'll be able to find them. I know that I'm going to have a coordinate right here at 4, 2, and right here, and that's at 2, 0, basically my x-intercept. I'm going to try to connect my graph as best as possible, so it's going to start going down, going through that coordinate right there, and it's going to form this L shape right over here, going off to the far right and going up. Over here, I'm going to connect these two here, and on the other side, I'm going to continue that line, trying my best not to cross that asymptote. And there's an arrowhead on there. This one here goes through that coordinate. It's going to turn. It's going to go straight down. Arrowhead on there as well. So there we go. Behavior is asking us, reading our graphs left to right, what's happening, which quadrant does it start off, which one does it end off at. Starting left to right, we are starting our graph starting in quadrant 2, and that line, if you follow it, it's going to end off in quadrant 4. The other line we have is starting in quadrant 1, and it's going to go off to quadrant 1 as well. Our domain, we want to write it in set notation, so using the curly brackets. So domain x such that, and it's easier to tell us in set notation what x cannot equal. Well, I'm going to look at my POD and my asymptotes. My POD is at negative 2, my asymptote's at 3, so I write x cannot equal negative 2 or 3, but x is an element of real, so it could be every other number after that. For my range, it's going to be the same thing, y such that, and I'm looking at my POD and my horizontal asymptote. So y cannot equal 4/5 and positive 1. But y can be an element of a real, meaning it could be every real number after that. And there we go. In the next example, pretty much the same thing as example 2. The only difference here is there is no graph for us to draw out, but we will be going through all these properties. The very first thing I'm going to do, though, of course, is to factor. So factoring the numerator, what do I get? I get x minus 2 and then x minus 1. Numerator. In my denominator, I'm going to factor out a negative 1, which lets me switch around my 2 in my denominator, my two terms there. And then in my denominator, I notice that that's called a difference of squares. So numerator x minus 2 still, x minus 1, negative 1 on the bottom, x minus 1, x plus 1. There we go. And again, I notice that I have two factors that can cancel out, so I'm going to cancel those out. And then I'm going to finish off writing out my equation. So I'm going to write out my equation as x minus 2 here over, and this negative 1 I can either multiply back into these factors or just leave it outside. So I'm going to leave it outside for now. This is x plus 1. There we go. We have my two functions done. Let's start off with our POD because we do have something that canceled out. So my POD is that x equals positive 1. If I have x equals positive 1, I'm going to sub that in for my y value here. So y is going to equal 1 minus 2, negative 1 of 1 plus 1. That's going to get me negative 1 in my numerator, negative 2 in my denominator, leading it to be 1/2. Therefore, we have a POD at x of 1 comma 1/2. Perfect. After we have our POD done, we're going to write down our vertical and horizontal asymptote. So vertical asymptote, again, that's always in your denominator here, is when x equals negative 1. My horizontal asymptote, this one here is a slightly bit tricky, so it's going to be y equals, again, looking at my degrees, it's 1 and 1, 1 over 1, but because of this negative 1 in front of that denominator there, I have a negative now right here, so my horizontal asymptote is going to be at negative 1. Let's go on. Let's do our domain and range. Domain. So we have x such that x cannot equal, and we're going to look back at our POD and our vertical asymptote. Negative 1 and 1 were our x values. X cannot equal negative 1 comma 1, but x is an element of a real. And then for my range, very similar. Y such that, again, starting off with y cannot equal, and I'm looking at my horizontal asymptote and my POD. That's negative 1 and positive 1/2. And y is an element of a real as well. We're more or less done this question. We only have to figure out our x and y intercepts, and we'll do that right here at the bottom. So x-intercept is when y equals 0, by the way. So in that equation, I'm going to set up as 0 equals x minus 2. All of that's divided by negative x plus 1. I clean this up by multiplying out my denominator to 0, so that 0 equals x minus 2. And then moving the 2 to the left, of course, that's going to get us x equals positive 2. So I'm going to have a x-intercept at 2 comma 0. On the other side here, our y-intercept is when x equals 0. And so I'm going to say y equals 0 minus 2. All of that's divided by negative 1, 0 plus 1. And I'm going to clean that up. So I have y equals negative 2 on top over negative 1 on the bottom. Of course, that's just positive 2. And so therefore we have a coordinate at 0 comma 2. There we go. That one's done. Moving on, we have example B here. And again, the very first thing I'm going to do is factor. So this one here up top, I can factor out an x. So that leaves me, or actually a negative x, that leaves me with positive x squared minus 16. And in my denominator, I'm going to factor out a positive x, leaving me with 2x squared plus 7x minus 4. In my numerator still, that's called the difference of squares there. So I have negative x multiplied by x minus 4 and then x plus 4. In my denominator, I can factor that any way I'd like. I'm going to use decomposition, and that's going to get me to something that looks like 2x minus 1 and a x plus 4. There we go. I notice that I have two factors that are the same. So again, I'm going to cancel these out, and I'm going to clean up my equation one more time. Oh, and I also have another two factors that are the same. The x's are the same there as well. So for my cleanup, my numerator, all I have left is negative bracket x minus 4 in my numerator. Denominator is just that 2x minus 1. There we go. So right away, let's start off with our PODs. We're going to have two of them. So the very first POD I have is at x equals 0. So that's what we cancel out. So when x equals 0, I'm going to solve for y. So that's y equals negative 0 minus 4. All of that's divided by 2 times 0 minus 1. Y here is going to be equal to positive 4 over negative 1, which is, of course, just negative 4. So we're going to have a POD at 0 comma negative 4. My second POD because I have a second one here, is going to be found at x equals -4. And again, finding the y value for it, we have negative 4 minus 4. All of that's divided by 2. -4 minus 1. There we go. So for this one here, we have y equals positive 8 over -9. There we go. So we have a coordinate at -4, comma, -8/9. Both of our PODs are done. Let's go and take a look at our equation. Do we have a vertical asymptote? Yes, of course we do. So our vertical asymptote is going to be at x equals positive 1/2. And again, how to get the half? My denominator set equal to 0. Move the 1 over, divide by 2. Horizontal asymptote is going to be at y equals, again, it's going to be 1, but there's a negative with it. So it's -1 because of that negative sign on the outside over 2, because that's the coefficient there. So I have a horizontal asymptote at -1/2. We're almost done, folks. We got domain and range here. So let's do domain and range right below. Domain x such that, and we're looking for all values x cannot equal. So x cannot equal 1/2, 0, or -4. You can write that in ascending order. So -4, 0, positive 1/2. X is an element of real though after that. Down here for our range, y such that y cannot equal, again I'm looking at my horizontal asymptote, this y value and this y value over here. So we have y cannot equal -4, -8/9, and -1/2, leaving me with y is an element of a real after that. We do want to finish off this question here. We're going to try to find the x and y intercept, and we'll do that at the bottom. So x-intercept, and that of course is when y equals 0. So I'm going to start off my equation with 0 equals negative x minus 4. All of that still divided by the 2x minus 1. Moving this 2x minus 1 out of the denominator by multiplying it. So I have 0 equals negative x plus 4, and I multiplied in that negative sign there. I can easily do that. Moving x to the other side, we have x equals positive 4. Therefore, we have an x-intercept at 4, comma 0. The next one is my y-intercept. Y-intercept here, and that's when all x's are equal to 0. So negative 0 minus 4 over 2 times 0 minus 1. And of course, let's clean this up here. That's positive 4 in my numerator over -1 denominator. So I have a y-intercept at 0, comma -4. But notice that this here, my y-intercept is the same as my POD up here. So this does not exist actually. So it does not. And that's due to the POD.